Hello everyone. So another question from JEE Advanced 2025. Only this time, this question is from thermodynamics with a little bit of laws of motion. Now what you have to remember is that not every thermodynamics question has to be about the process involved. You know, जब भी कभी thermodynamics का question आता है, so first thing जो हमारे दिमाग में आती है, वो आती है आइसोथर्मल, आइसोबारिक, आइसोकोरिक, एडियाबैटिक. ये गाना हमेशा नहीं गाना होता है. अब अगर हम इस क्वेश्चन के बारे में देखें, let's first read the question. It says that the left and right compartments of a thermally isolated container. आधी चीजें ना तो क्वेश्चन की लैंग्वेज में ही होती हैं. Thermally isolated container. तो एक कंटेनर है. This container is insulated. Very big information. No heat comes in, no heat goes out. It has a length L. It is separated by a thermally conducting movable piston of area A. Another vital information. There is a piston here. Only this piston is thermally conducting. Which means that if there is a piston which is thermally conducting, given sufficient amount of time, the temperature on its both sides will eventually become equal. So that has an area A. And the left and right compartments are filled with 3/2 and 1 moles of an ideal gas, although it hasn't been mentioned what kind of a gas it is, monatomic, diatomic, so it must not be relevant. In the left compartment, the piston is attached by a spring. So यहाँ पर एक spring लगा है, and the moment this spring is presented in the question, it becomes very clear that some laws of motion, maybe even some work per energy, might be included. It has a natural length of 2L/5. Now, since the number of moles are not the same, the thermal equilibrium, the piston is given at a distance of L/2. So these gases are, both sides there are gases, and they are in equilibrium, and it is given in the question that in equilibrium the piston is at a distance L/2. So this distance here is 0.5 L, and this distance here is also 0.5 L. Under the above conditions, if the pressure in the right compartment is P, find alpha. So here, right compartment, let the pressure be P2. Left compartment, let the pressure be P1. So basically, we have to find P2. सारी कहानी P2 निकालने की है, that's it. So once again, since there is a spring in the system, force applied by a spring will be variable. As the piston moves, the force applied by spring is variable, which means the pressure changes. Because of heat conduction from this part to this part, the temperature changes. Of course, the volume is changing. There is heat exchange between the two parts. So this is none of the process, but always remember, जितने भी process आप लोग पढ़ते हैं, उन सारे process में एक Boss equation होती है. हर एक result उस Boss equation से आता है, and that in thermodynamics is PV equal to nRT. और वही इस क्वेश्चन का बेस है. 2-3 इक्वेशन लगनी है, कहानी खत्म. लेफ्ट हैंड साइड पे लगाते हैं, तो लेफ्ट हैंड साइड का प्रेशर कितना माना है मैंने? P1, वॉल्यूम इज एरिया इंटू लेंथ, नंबर ऑफ मोल्स कितने हैं? 3/2, एंड टेम्परेचर इज लेट्स से T. सेम इक्वेशन राइट हैंड साइड पे लगा दो. वहां प्रेशर है P2, वॉल्यूम उसका भी इतना ही है, उसके नंबर ऑफ मोल्स 1 है, टेम्परेचर इज स्टिल T. एंड फाइनली, सिंस देयर इज अ स्प्रिंग इन्वॉल्व्ड, if you draw the FBD of this spring, there is a force here acting, pressure P1 into area A. From here, it is P2 into area A, and there is a spring force Kx, where x is the extension. Now the natural length of the spring is 0.4 L, final length is 0.5 L, so the extension of spring here is only 0.1 L. So when I apply the force equation on this, I get P1A to the right is P2A to the left plus K into extension 0.1 L. So from here and these two equations, I only have to find P2. So if I divide these two equations, I will get P1 divided by P2. Just divide these two, equal to 3/2. So P1 becomes how much? P1 becomes 3/2 times P2. This P2 goes here. This becomes, and the moment you solve it, you get P2 as KL/A times 1/5. Solve this equation. That's it. You are required to find the value of alpha The coefficient is KL by A. So KL by A times alpha. The answer to the question, alpha is simply 1 by 5 or 0.5.